In order to evaluate limits graphically, we need to start by graphing our function. Once the function is graphed, we should then trace along the function from both the left and the right sides of the indicated x value and find the y value that the graph is approaching for that given x value. Let's take a look at a few examples. For our first example, we're asked to find the limit as x approaches 2 of the function x cubed. Take a minute and graph your parent function y equals x cubed. When you're ready, come back and we'll find the limit as x approaches 2. Here's what your graph should look like. As noted earlier, in order to find a limit, we need to trace along our function from both the left and right sides of the x value we are approaching. So we're asked to find the limit as x approaches 2. So we're going to trace along the function until we get closer and closer to our x value of 2. Here our x value is negative, 0, getting closer, 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 and right around there, our x value is equal to 2. That's coming from the left. Now let's check the right. Even though most of the right side is cut off, you will see that we are approaching the same exact y value from the right-hand side of our function as well. So the limit as x approaches 2 of the function x cubed is this y value right there, which is 8. Let's take a look at another example. Our next example asks us to find the limit as x approaches 4 of the function the square root of x minus 3 plus 1. In order to graph this function relatively easily, we can address our shifts. Our new origin for this particular function is positive 3, 1. So if we start at our current origin, move right 3 and up 1, which is right there in that area, you can now graph the parent function y equals the square root of x from that new starting point. Take a minute, pause the video once again, and graph your function. Come back when you're ready to calculate the limit. Here's what the graph of your function should look like. Again, we're going to trace our function from the left and right side as we approach the x value of 4. So coming from the left, we're getting closer and closer to a certain y value, and coming from the right, we're getting closer and closer to that same exact y value. What y value is it that we're approaching as x approaches 4? It is right there, y equals 2. So the limit as x approaches 4 of the function the square root of x minus 3 plus 1 is equal to 2. Now you're probably thinking by now that all we have to do is plug in the x value that we're approaching into our function in order to find what the limit is. Unfortunately, that's not always the case. Let's see why. For our next example, we're asked to find the limit of a piecewise function as x approaches 2. I'd like you to, again, pause the video, graph your piecewise function, and then we'll talk about what the limit is as x approaches 2. Here's what your piecewise function should look like. We have the equation y equals 1 everywhere except when x is 2. When x is 2, our y value is 0. Now, if we just try to plug in the x value that we are approaching with our limit, our answer would technically be 0. However, with limits, even though our function value when x is 2 is 0, this has no impact on the limit. We need to stick with the fundamentals of what it means to be a limit. It's asking us, what is our function approaching as our x is getting closer and closer to 2 from both the left and the right? If we look at our graph, as we get closer and closer to x equals 2 from the left-hand side, and also from the right-hand side, we're zoning in on the same exact y value. Even though it's not a function value, our limit is equal to 1. Let's do another one. Our second example that proved that you can't just find a limit by plugging in an x value into your function is this piecewise function. Find the limit as x approaches 3 of the piecewise function x plus 1 everywhere except when x equals 3. Again, I'd like you to pause the video, graph this piecewise function, and we'll discuss what our limit is. Here's a look at what your piecewise function should look like. If you remember, a limit is asking us to find what function value is being approached as we get closer and closer to a given x value. For this particular example, we're asked to find what our function value is as x gets closer and closer to 3. So we have to trace along our function, and as x gets closer to 3, from the left and from the right, we are approaching the same y value, which is right here, which is 4. Even though f of 3 is equal to 2, that does not matter. We need to look at what our function is approaching from the left and the right as x gets closer and closer to 3. So our limit as x approaches 3 is equal to 4, right there.